Let me start with this algorithm, how it is used for problem solving. So here are the some 7 or 8 steps to understand this solving basic procedure for real-time problem solving technique. First, you have to understand the problem and you have to decide on what computational means, what approximate solving technique we are going to use, and how you are designing an algorithm, how you are proving your correctness, and how you are analyzing the algorithm, and how we are coding the algorithm. The first step is understanding the problem. We already know how the problem can be understand. You have to define this. In this step, you are just going to define a problem, like what all the prior input we need. It is very important to specify exactly the set of inputs to the algorithm, and what are all the techniques here, what are the computational device we are going to use, whether it is a sequential process or it is a parallel algorithm, and choosing between exact and approximate problem solving. To choose between solving the problem exactly or solving it approximately, classified as exact algorithm, approximation algorithm, and we just need to decide on the data structure, which plays a major role in designing and analysis of an algorithm plus data structure, which will give you the program. Algorithm design techniques. Learning these techniques is utmost importance for the following reason. First, they provide guidance for designing algorithm for new problem. Second, algorithm are the cornerstone of computer science. And what are the methods for specifying algorithm is pseudocode, flowchart, and programming language. And proving an algorithm correctness. Once an algorithm has been specified, you have to prove it for correctness. Means you have to check it for errors. A common technique for correctness is to use the mathematical induction problem, which will provide you some iterations, and how we can analyze an algorithm in an efficient manner. We have time efficiency as well as space efficiency. Coding an algorithm. Most algorithms are designed to be ultimately implemented for creating any computer program. Programming means which will be a peril and an opportunity. So this what any this algorithm problem solving steps can be applied to any real world problem. Even we are using this design thinking technique in our college, which is similar to that one, which we can apply it for real world, any real world problem. So the basic thing is, first we need to define a problem and you have to understand the problem, and the second is you have to decide on which computational efficiency or which computational what technique you are just going to use it to apply it for any problem. And the third one is you are going to design an algorithm, and the fourth one is once you have designed, you have to prove it for the correctness. And the next one is once it is corrected, you are just going to analyze it, and at last you are just going to code the algorithm. And before coding, the basic steps or the understanding step is called as the algorithm. Even a layman can easily understand what is what. Algorithm mainly it is the basic building block for any program, where a layman can understand. It will be written. It should be written in a simple English manner. And there is a vast difference between algorithm and pseudocode. Whereas pseudocode are called as mnemonics, where we can specify the code in what to say, like in an instruction manner. Say for example, add A and B, or multiply a and b or subtract a and b. So likewise, it will be in a instruction mnemonics basis, as how an assembler or a microprocessor will be given instruction. In the same way, the pseudocode can be written. And the next one is called as the flow chart. Flowchart where we can have the pictorial representation.